this is Mike Barrett. We are in our headquarters here in Chicago, Illinois. Today I'm joined by Ted White, president of the Soundproofing Company. Ted has joined us from all the way down from Michigan. Thanks a lot for coming, Ted.
Absolutely, great to be here.
Ted and I have worked together for several years in a mission to improve sound transmission in our multifamily homes. This is an area where a lot of builders struggle to understand the mechanics of how sound is actually moving between units, me included, before running into Ted. And I think it's a big problem in Chicago and other markets because people don't know that it's a problem until they move into their unit and they're hearing their neighbors stomp their feet above them, or they're hearing their music, or a dog or a pet of some kind, and you're kind of trapped once you're in a unit like that and the proper measures haven't been taken prior to you moving in. So Ted has helped us develop systems to mitigate that sound transmission above levels that the code specifies. And I think that's something where I just want to lead in with Ted. Ted, you know, minimum code requirements for sound transmission are something that you don't think are adequate. Will that be accurate?
You're right. Just anecdotally, you know, our most common phone calls are, or among them would be people totally dissatisfied with a brand new purchase that they've made, whether it's a condo or home. Interestingly, we get asked sometimes if we would vet what the builder did to see if they have actually met code. It's just hard to believe that a building that leaks that much noise still meets code. So the key is what you've done is you have to go well beyond code if you're going to, you know, give somebody peace of mind, really.
Yeah, and I think that's, you know, paramount to understand is that the code as it is right now is not necessarily comfortable for a person to actually live and feel privacy and security in their home.
Right. If you built a home or a structure to code, you're definitely going to hear your neighbors. There's no question about that. If you don't want to hear your neighbors, then you've got to, from this point of construction, you've got to design it differently and build it differently if you're going to surpass code and actually have something that you can be comfortable in and not hear your neighbors.
And Ted, can you speak to the different types of noise that people could experience?
Right, because they're not all the same, and some of them are a lot worse than others. But basically, the common noise that everybody thinks of, which we would call airborne noise. It's you and I speaking, or we have a radio, TV going, and that airborne sound is able to pass through the structure into somebody else's residence. Okay, so that would be airborne sound. The other one,
is there a name for that?
Just airborne sound.
Is that what STC is considered?
STC would be a measurement, sound transmission class. Okay. STC would be a measurement, like miles per hour.
Gotcha.
And just sort of to assess whether something's got more isolation for airborne sound than another. The other key and really worse sound isolation problem would be the footfall noise, or we would call that impact noise. And the real reason why it's so much worse is because airborne noise is fairly diffuse. Like we're talking now, there's not a lot of energy hitting any square inch of surface. Whereas a footfall noise, think of a high heel, all of the energy from that strike is concentrated down to one little square inch. And that laser-like concentration wants to drill straight down to the unit below. Not such a problem back when everybody had carpet and pad to relieve some of that impact, but I mean, obviously everybody's going hard surfaces, and so the impact strike is much worse.
And so is that measured, that's measured in
That would be that's an IIC, Isolation Impact Class. So that's another sort of isolation. Worthy to note here too that neither STC nor IIC, the only measurements and metrics that we have, neither of them measure the low frequency bass, which is really where all the problems are. So it's entirely possible for somebody to have a high STC system, but it bleeds bass like crazy. So we have to have an eye beyond simply STC or IIC to incorporate the low frequency bass component of the problem.
So you're suggesting that the footfall or the high heel is really the one that's the most difficult to mitigate?
It's the most difficult to mitigate because you have to do something to the entire surface of the floor. If you're doing it in a retrofit, that's going to raise your floor, hard to do. If you're doing it from the beginning in the design, as you guys do, then it's all taken care of from a height standpoint. The other key thing is that you also are going to want to address the ceiling below. And a lot of times, if it's a retrofit, you don't own the ceiling below, and so not a place you would work.
That definitely makes it way more difficult in these, say, a 3-unit building in Chicago where you have the person in the middle floor is hearing noise from below and above. Yeah. They're kind of stuck because the third floor person can't necessarily come into their unit and make changes for them.
Right, and generally by the time anything like that comes along, nobody's speaking to one another anyway. They've already had these attempts and it's just not working, so there's generally not a lot of neighbor cooperation.
From my experience, the traditional method of mitigating noise between units in smaller multifamily buildings in Chicago is lightweight gypsum concrete.
Right.
And that is poured very thin. We would typically see 1 inch to 1.5 inches of that. And in your opinion, is that a good solution for mitigating all these types of noise?
No, not in a long-term perspective, because number one, there's generally not enough mass associated with that. That would be number one. Number two, the spring, okay, any piece of mass, in order to isolate, you have to put it on some kind of spring. And so typically underneath a poured gypsum is a mat, and the mat over time, especially in traffic areas, can collapse. So if the mat collapses, you've got contact now, you have no more spring, so you've got direct conduction going straight down. And if you've got a hardwood floor built on top of this, you would never even be aware of it.
The mat that you talk about with the lightweight is something that I'm not even sure a lot of people are doing. I think they just pour that gypsum, which is not really doing anything.
That's the worst of scenarios. It's not really doing anything at all, exactly as you said. If you're just adding a whole layer of mass right on top of what you've got direct conduction still. You have to put a brake in the system, typically a spring.
Okay, that makes sense. All right, thanks, Ted. Let's head out to one of the job sites and we can take a look at the system that we are installing, which is an improvement on the standard gypsum poured floor.
Okay, let's go.
Thanks, Ted.
Thank you.
Hey guys, Ted and I are here at 4102 North Sheridan. This is a 32-unit rental building that we're working on in the Uptown neighborhood in Chicago. So Ted and I just talked about a lot of these concepts in our office, and we wanted to come out of in the field and see how this translates. Where we're standing right now is a typical floor. We have wood trusses, we have a layer of plywood on top of that truss. In a lot of scenarios, that's all someone will do. You'll just put your flooring right on top of that. But you'll see as we walk the progression of how this system works. Ted, what is this first layer that we're doing here?
So this would be our Serena mat. It's a calibrated 3/8 inch thick rubber that is used as a spring. So everything else that goes on top of it is going to be essentially oscillating on this rubber spring.
Okay, so here's our spring. On top of the spring then is a loose laid piece of 3/4 inch OSB, and the reason that needs to be loose laid is what exactly?
No connections. Okay, so we want this floor to oscillate as freely as possible, and if you've got screws all over the place, it's a little detail, but if you put the screws in place, your spring is locked in place.
Okay.
And you won't get any isolation from that. So that's why the first layer is floated on top of the rubber.
Okay, so we're floating this layer on top of our rubber mat or spring, and then as you can see, we have another layer of 3/4 inch plywood running the opposite direction. So this floor consists of 3 total layers of 3/4 inch plywood. But between these 2 layers, what do we do, Ted?
So in between the 2 layers of topping plywood that we have a layer of this viscoelastic damping compound called green glue. And it is used to damp the vibration, minimize the vibration. So when this is all dry, this impact won't conduct. Okay, the impact is isolated with 6 inches around your foot.
So this helps with that footfall noise or
footfall noise going downstairs.
That we were talking
Absolutely,
about.
It's the first big push. We want to keep the energy from the footfall out of the structure, and so this is our first glance at that.
Okay, and this does get screwed down, but the key thing again is for it not to screw down into that Serena mat, correct?
Don't want it into the Serena mat. You just want to cinch the 2 panels together, squeeze the glue out to a thin film, and you're done.
Gotcha. Another reason why we do this before framing any of our interior walls is to completely separate this floor from the walls that connect this floor to that floor, which is another key point. If you go in and frame all your interior walls first, then you are missing out on this spring and whole system that decouples this floor from the floor above, which is also an important detail to keep.
Right, and that's actually a good example of what the Barrett team does that I really appreciate is, you're looking at this from a larger perspective. This is not necessarily a convenient way to go, to have all the interior walls built afterwards. However, the isolation that you're gaining from that is just enormous. I mean, imagine banging on a wall, the sound traveling down, it meets this floor, it doesn't go down to the neighbor below.
Sure.
So it's fantastic.
And then, as you can see, we have, open web wood trusses here. And so part of this system involves the ceiling as well as the floor. It's all working together. So what is the recommendation in the ceiling? Right,
so other than some insulation that you'd have in the ceiling, just to damp the sound that's in the cavity, we would understand that while we're reducing a lot of the energy from entering the system, you can't reduce it all, okay? And so if the drywall were installed directly to the joists, it becomes a large speaker. You're hearing whatever remaining sound there would be. If we're able to install the clip and channel system, like you guys do, then the drywall on the ceiling is also installed on a spring, okay? Much more isolating. You're really dropping it down to near zero at that point.
We do the clip and channel, we put up a layer of drywall, and then we do additional green glue on our second sheet of drywall.
Yep.
And put that up.
Cushions.
And then same idea, you cannot screw all the way up into the wood truss because same as the floor, you go all the way up into the wood truss, it's going to defeat the purpose of the whole system.
Locks it into place, right? We want everything oscillating on its own spring.
Right, exactly. One other thing that we like to do too in multifamily is not use recessed can lights. We will use junction boxes and we will use skinny LED discs that mimic the appearance of a recessed light, but having massive recessed lighting all over this cavity is not really going to help our system either, will it?
Putting a lot of holes in your barrier is the problem, so no. And again, that's another example of where, these little details all really add up to a lot. So the can lights that you described, the insulation, all these things, that's why you're seeing the success you are. You're really paying attention to all the details.
Gotcha. Well, thanks for explaining all that, Ted.
Very good.
Very helpful.
Thanks for having me.
All right.
Take care.
We've used this soundproofing system in over 50 of our Chicago apartments. Here's Mike Root, our property manager, talking about the client experience and how the results of this system have increased our customer satisfaction.
I think what sets the Barretts apart from other developers of multifamily apartments is they take their knowledge of luxury single-family home building and they bring those ideas to apartment building. Great layouts, beautiful finishes. I'm not going to say that's the easy part because I know that's difficult to do, but what sets them apart is saying, we want to know that living here is going to be comfortable. And so they go the extra mile of including features in their properties and in their construction that'll set their buildings apart from their competitors.